You're welcome to Waidsum University. Today we are looking at chapter 5. Okay, this is chapter 5 and of our network and cybersecurity course. And remember, this course is about Cisco's cybersecurity. Okay, so chapter 5 we'll be looking at implementing intrusion prevention. Okay, the ways and means of implementing intrusion prevention, right? So we're going to look at the ways and the means and the method and the types of implementation of IPS. Okay, IPS intrusion prevention system. We're going to look at all the different ways of implementing intrusion prevention system. But before we talk about that, let's quickly take a look at the whole network. Now, we say one of the things that do affect our network is the worms and viruses. They spread all across the network in a few seconds. The worm, viruses, and Trojan horse, all of these things, they can attack our network as fast as possible, right? So in this, we have what we call the zero-day exploit. Now, what in zero-day exploit, we talk about the zero-day attack and the zero-day hour. Zero-day attack, that's the zero-day threat, is a threat. Okay, it's a computer attack that tries to exploit the software vulnerability. Okay, taking its time to exploit the software vulnerability. That's what we call the zero-day attack. Then 0 hour, it describes the moment when the exploit is discovered. When the exploit is discovered, that moment you discover the exploit that is taking place in the network is what we call the zero hour. Okay, the 0 hour is the hour, the time you discover that attack that is being taking place in your network. Now, quickly, let's still on the zero-day exploit. How does an organization stop the zero-day attack? How? Because where firewalls cannot stop this kind of attacks. Firewalls cannot. Antivirus cannot. Right? Antivirus cannot. So that's taking us to this chapter. The objective of this chapter. Firewalls cannot stop in a network security. Firewalls cannot stop this kind of attack. Okay? And antivirus cannot stop this kind of attack. ACLs that we've implemented in chapter 4 cannot stop this type of attacks. So how then do we stop this type of attack, the zero-day exploit that's taking place in our network? We say firewalls do not stop malware or zero-day attack. So since firewall cannot stop, there's still there's still a gateway loophole wherein this kind of attack this exploit can still take place. The zero-day exploit attacking the network. See, it's attacking this entire network. So this exploit is attacking this entire network. So how do we stop it? That will lead us to what we call the IDS and IPS. It will lead us to what we call intrusion detection system and intrusion prevention system. So since the malware cannot, the ACL cannot, the antivirus cannot, all of this cannot stop all of this, then we need to find another way to stop all this time. How do you protect your computer? There are several ways of protecting computer from attack, okay, from the DOS, denial of service, from hacking, from so many things that are happening on the net and on the computer system or in the network. So one of the things you do constantly is you sit there looking at the task manager for nefarious processes. Do you do that? Or you look at the event viewers log, looking for any suspicious things. So one of the things we normally do with computers is that we rely on the antivirus software, right, and firewall features to help us prevent any nefarious activity on the system. But like we said, the firewalls and the antivirus are not enough for zero-day attack on a network. So how do you now protect a network if the firewalls are not enough to protect zero-day attack, and if antivirus are not enough to prevent zero-day attack? So if we say let's decide, say we want someone to continuously monitor the network and analyze the log files, this will take a lot of time. This will time consuming, energy consuming, waste a lot of resources, and so on and so forth. So you have to dedicate some staff to be manually monitoring the network and analyzing the files. And in that process that you're doing that, even the attacker would have attacked the network. The attacker would have, the time you're analyzing the logs, the file logs, on the computer, the attacker would have gained access and even hit the network. So this is not a very proactive way of preventing preventing zero-day attack in a network. So we have to find better ways. We have to find better standard, better ways of preventing this type of attack on the network. So that leads us to profiling solutions. And one of the solutions that we've come up with is that we have to develop two solutions have been developed actually. Okay, we just need to be updating and improving on it. One of it is called the intrusion detection system, which is called the first generation, and the second one is called the intrusion prevention system. So the intrusion detection system has been developed, right? The intrusion detection system has been developed and has been developed, and it's called the first generation, and the intrusion prevention. Now, these two are not mutually exclusive. You know, when two things are mutually exclusive event, the occurrence of one will prevent the occurrence of the other one. So, which means, since this one is only for detection, intrusion detection system does not actually prevent the attack. It only detects attacks. It does not prevent attack. And it was first generation. So what we can do is also to concurrently install intrusion prevention. So when the intrusion detection detects the attack, the intrusion prevention is able to prevent the attack from taking place in our system. So we say both the IDS, which is intrusion detection, and IPS technology, they're just set of rules called signatures. So we'll be hammering on signatures as we go down in this lecture. There are a set of rules called the signature to detect typical intrusion activity that is taking place in our network, right? Okay, now let's quickly go on because we have a lot to do today. Now let's take a look at IDS and IPS sensors, because these systems are just a bunch of sensors developed to detect and to prevent intrusions by the zero-day attack or any other attack on the network. Okay, because this is an advanced system. Now we've taken a step above firewall. We've taken a step above ACL, installation of ACL, firewalls. ACLs are types of firewalls, okay, or technology that is used for installing ACL. Installing firewalls are called ACL. We've taken a look at that in chapter 4. In chapter 5, we're looking at intrusion detection system and intrusion prevention system, which are sensors developed by Cisco, but they're also developed by other manufacturers. But in this course, we're looking at Cisco systems. Okay, so these are sensors that are developed by Cisco to detect, to identify. Okay, that's what we mean, to identify any program, any problem, any something that is going to be an attack on your network. So it will identify it, it will prevent it, and it will also kind of immunize the system against such future attack. We're going to talk about this extensively later on. So we said the IDS and IPS technologies are deployed as sensors. So they are used as what? Sensors. So we should know IPS technology and IDS technology, both of them are used as what? Sensors. So one of the research we can do is to improve on the sensory part of this IDS and IPS, okay, for masters and PhD. We can develop more improved version of the sections that is compliant with the Cisco's technology, okay. So now we say there are sensors to do what? They are configured in where? In router. A router configured with Cisco iOS IPS software, okay. They are deployed in router, meaning you deploy it in router, you use it in router, this software, okay, or this technology, this sensory technology, you use them in router, you use them in a network module, network module that is installed in router as ASA router. You know, we have ASA router that help to prevent all this attack on network, or a catalyst switch, a switch that can behave as a router. And then we say this APS and ADS, IPS and IDS, IPS and IDS can also be used not only on the router, not only on the network configured modules. They can also be used in an appliance specifically designed to provide dedicated IDS and IPS service. Okay. Not only that, they can be used. This technology can be used on host software. Okay, that is running on individual client, on your client and your server. So you can use this. We're mentioning where you can install this technology, this sensory technology, okay, in router, in network module, in appliances that are designed for that support IDS and IPS and host software also. Okay, so that's it. Now let's move on quickly. We say now let's take a look at the first one, which is intrusion detection system. What is it and how does it work? And IDS, what it does is that it monitors traffic offline. Okay, it monitors traffic offline, unlike the IPS, which monitor traffic inline, not offline. For IPS is inline, monitors the traffic inline. So that's why I say, since they are not mutually exclusive, we can actually concurrently install both software or both technology. They are sensors, both sensory technology in our system, in our network, okay? So that they can complement each other, so that they can both complement each other. Now we say IDS, they monitor traffic offline and generate alerts, alert logs, like alerts the system of an intruder, of an intrusion into the system. Okay. So what the IDS does is to generate alerts. We're going to talk about alert system in the CCP, Cisco. We'll talk about it in the CCP. Okay, in the Cisco Configuration Professional. Okay, a platform for installation and monitoring and all of this software. Okay, and configuration also. Okay, we say IDS monitor traffic offline and generate alert logs when it detects any malicious traffic occurring in the network. Any type of malicious traffic, whether it's a reconnaissance attack that is taking place. So this IDS is able to detect reconnaissance attack, is able to detect access attack, any attacker trying to gain access to the network, is also able to detect denial of service attack. So these three types of reconnaissance, access attack, and denial of service attack, these three attack, this IDS is able to detect them and generate alerts. Alert that like an alarm, generate an alert, alert the system of an intrusion. Okay. Then we say it's a passive device. It's not an active device because it's operating in offline mode. So it's a passive device, and it's able to analyze copies of the traffic stream. Okay, it's able to analyze the copy of the traffic. So this is an intrusion detection system. You can see this sensor is able to detect any attacker that is gaining access to this target that is about to gain access. Just assuming that this attacker is, let's assume this is the public network and is coming to gain access to the management console and also gain access to this target. So once we install a sensor, whether being it intrusion detection or intrusion prevention, but in this case we're looking at intrusion detection system. Once we install the intrusion detection, it's able to detect it and generate alert logs and inform the system of a possible attack that is about to take place by generating signatures, which we're going to talk about later on. Now, we say the three types of attack that this can detect. One of it is the reconnaissance attack, the access attack, and the denial of service attack. So we say it's a passive. These sensors are passive device and is able to analyze copy of the traffic stream, and it only requires a promiscuous interface, and it does not slow network traffic. These are some of the features. It does not slow, the IDS does not slow. So here we can write IDS. The IDS does not slow the network traffic, or like the IPS. IPS kind of slow the network traffic because it does more than detection. It prevents. It also immunizes the system against future attacks. So for IPS, I'm talking about IPS. Okay, we're going to come to that. But IDS does not do all of that. IDS only detect and analyze the copy of the traffic to be able to detect whether there's an attack on the network or not. Okay, it also allows some malicious traffic into the network. It may not be able to do because it's only working in offline mode, so probably sometimes allows some malicious into the network. Now let's go to intrusion prevention system. In the intrusion prevention system, it builds, we say here, we build the sensor here, over here, okay? We build the sensor over here to detect, to prevent what is going to this root bucket, bit bucket, and also to detect what is going to the management console and whether this target, whatever is coming here, let's assume this is the attacker or this is the attacker. So this is able to not only to detect, also to prevent access into these gateways, access into these gateways. So now let's take a look at the features. We say it's built upon the IDS technology. It's a build upon the IDS technology. So it's like IDS has already been built, the intrusion detection system, and modification of it or addition to it led to what we call the intrusion prevention system. Okay, so it's a build upon the IDS technology to detect attack, but not only detect attack, it can also immediately address the threat. It can address the threat, not only detect it, it can address it. So an IPS is an active device because all traffic must pass through it. All traffic. If it's coming from here, it will pass through it. If it's coming from here, it will pass through it before it will have access to these gateways. All traffic passes through it, so it's an active one. For the other one, it's a passive one because not all traffic passes through it. Not all traffic passes through it. Okay, based on the way it's designed. Okay, the accessory is designed. So, but IPS is an active one because all traffic must pass through it. Okay, so it means it's in inline mode. It's not an offline mode. It is generally refers to an inline mode. It's not offline, and it works inline in real time to monitor layer 2 and layer 7. We're going to show the layers where this monitors. Layer 1, layer 1 is the physical layer, layer 2 is the data link layer. Layer 2 through layer 7, meaning both the data link layer, which is layer 2, the layer 3, which is the network layer, it monitors it. Layer 3, which is the layer 4, which is the transport layer, it monitors it. Layer 5, which is the session layer, it monitors it. Layer 6, which is the application. Layer 6, which is the layer 6 is layer 7 is application layer, right? Layer 6 is okay. We'll come to that. So, but all from layer 2 to layer 7, what it does is that it does the prevention. It prevents. It is active. It's inline. It's working. It does a real-time monitoring. It monitors from layer 2 to layer 7 and monitor the traffic and all the content of the traffic and ensure that any malicious, any unauthorized, any daybreak attack or whatever the 0 or 0 day attack that is coming to the system is being blocked. Is being detected and is being blocked. All the contents are blocked. So it can also stop single packet attack from reaching the target system, which IDS cannot. IDS cannot stop a single packet attack from reaching the target system, but IPS can do that. Now let's take a look at it. Still on the intrusion prevention. The intrusion prevention has the ability to stop attack against the network and provide active defense mechanism. How? It does three functions, three main functions. The intrusion prevention does three main functions. One is detection. Okay, detection is able to identify the malicious attack on the network and the host resources. That's the detection. Number two is able to stop the detected attack from executing itself into the network. So it's able to stop it. That's the meaning of prevention. Able to stop it from manifesting itself manifesting itself or executing itself on the system. Number three is the reaction. Reaction is able to immunize the system from future attack from any malicious source. So intrusion prevention system or the intrusion prevention sensors that are being developed, they are able to carry out these three functionality. One is able to detect, meaning is able to identify malicious attack on networks and network resources or host resources. Is able to prevent that, stop the detected attack from executing or manifesting itself. And the third one is reaction, is able to immunize the system from such attack, future attack. Okay. Now we say either technology can be implemented at network level. Both the IDS and IPS can be implemented in the network level. Actually, IPS can be implemented from layer 2, the data link layer, up to the application layer, which is layer 7. Okay, so it can also be implemented at we said the network layer, host level, the network level, the host level, or both both for maximum protection, both the network and the host level for maximum protection. Here are some advantages of IDS and IPS. Just comparison. IDS is promiscuous mode, while IPS is inline mode. Promiscuous means offline. Okay, it's offline. So it's not able to detect everything, or not able to stop everything. So, but it has some notable advantage. It has a good no impact on the network, meaning it has a good latency and no G3 on the system. No network impact if there is a sensor failure or sensor overload. So if the IPS of technology, which is the sensor, if it's overloaded, it will not have impact on the network. These are some advantages, but the disadvantages are still a bit more. That's why there was improvement on it to get the IPS. Now, one of the disadvantages stops trigger packets. Every trigger packet stops it, whether it's an attack or not. It can use stream normalization techniques and so on and so forth. But now let's take a look at the IPS, the advantages and the disadvantage, okay, of the IPS. Okay, these are advantages of IPS, sorry. IPS stops trigger packets. Any trigger packet, IPS will stop it. And can also use stream normalization techniques. That's IPS for you. Okay, these are advantages of IPS. Why these are advantages of the promiscuous mode, which is called the IDS. It has a good latency or jitter level, no network impact, even if the sensor is overloaded or the sensor has a failure or it has some issues, it will not affect the network. These are advantages for this. But now let's take a look at the disadvantage for each of them. The IDS response actions cannot stop trigger packet. It's a disadvantage, cannot stop trigger packet. Or like the IPS can stop trigger packet. And IDS correct tuning required for response action. If you don't tune it nicely, you will not get a response. And we'll talk about tuning in the configuration mode when we start looking at the configuration. And then more vulnerable to network evasion techniques. Any network evasion techniques that is advanced, this IDS is vulnerable, can be found wanting. Okay, but for IPS, some disadvantage it has, some impact on the network, that the latency and jitter. Okay, it doesn't have a good latency, and then sensor failure may affect or overload may affect the network. Okay, now let's move on. So which should be implemented? I think we should implement both. Okay, the technologies, they are not mutually exclusive. Since they are not mutually exclusive, we should implement both the IDS and IPS. Okay, we implement the IDS to validate IPS operation, because IDS can be configured for deeper packet inspection offline, allowing the IPS to focus on few but more critical traffic pattern inline. So IDS is able to do like more of screening, is able to do more of deeper offline work than the IPS. So it's better we implement both IDS and IPS technology to prevent any malicious attack on our network. Now, deciding which implementation is used should be based on what the security goals and objective of a network, okay, and the policies of the network. Now let's take a look at the network-based IPS. Okay. Now, this network-based IPS implements, or its implementation analyzes network-wide activity, looking for any malicious activities that is found on the network. Now, in doing that, we have to configure it, or it is configured to monitor known signature. It is configured to monitor known signatures. IPS is configured to monitor known signature because it's working in inline mode, not offline mode. But it can also detect abnormal traffic pattern. It is able to discover any abnormal traffic pattern, okay? And it's also configured on dedicated IPS appliances. These are some where you can find it. Dedicated IPS appliances, and also dedicated on the integrated service router, ISR routers, integrated service router. It's also configured, we are telling where should we configure the IPS, right? Where should we configure this IPS? We configure them dedicated IPS appliances, any IPS appliance. Okay, we also configure them on integrated service routers. We configure this IPS, this technology on ASA firewalls appliances. We also configure them on Catalyst 6500 network modules. Okay, so these are where we should configure this, where we should configure these signatures. Okay, where we should configure these IPS signatures. Okay, that helps to detect any threat to our network. Okay, now still on network-based IPS. Now, in this case, we will be looking at the features. You remember we said they are sensors. These IPS, they are sensors. So these sensors are connected to network segments. Okay, they are connected to the different segment. Meaning, if you have a network, you can put one sensor here. You can see here there is a sensor here, which is an IPS. You can put another sensor here for the management server to monitor the management, to prevent any attack on the management server. Okay, we can put one sensor here to monitor the web server and the domain name system server. We can put one IPS here. All the sensors are the IPS in this regard, IPS and IDS. So these are different segments. Okay, you know, this is a segment. This is a segment. Let's see if we can change the color. This is a different segment of the network. It's called corporate network. This one is called corporate network with a router here as a gateway to other network. This is a different segment where you have the management server, and this is a different segment, and this is a different segment, and then we have the untrusted public network, which is also a different segment. So you can see here we have about 3 to 4 segments. So what we are saying is that we should install. What we are saying here is that the sensors are connected to network segments. So you should have the sensor installed on the different segments of the network, not just one sensor to monitor everything. That's the point we've made here. Okay. So a single sensor can monitor many hosts as much as it can carry. Okay. Then another features of the IPS, network-based IPS, is that sensors are network appliances tuned for intrusion detection analysis. Their job is to detect and analyze any intrusion, any threat to the network. Okay. Now the operating system is added with this system, and the hardware is dedicated to intrusion detection analysis. The hardware is dedicated to carry out intrusion detection analysis while the software is added. So sensors are network appliances that are tuned for intrusion detection analysis and applications. Then another feature is that growing networks are easily protected. Now, what do you mean by growing network? You know, a growing network, you have new hosts and devices. They are always added constantly and continuously without adding any sensor. Let's say you add new computer or new printer to the network, it still work fine, except you are adding too much. Okay, when it gets too much, then you need to bring a new sensor. So when you're increasing your network, new sensors can easily be added to new network. When you create a new network, then you add a new sensor. But if you are just adding few computers, few hosts, then the already existing sensors can protect the system. Okay. So you can see Cisco network IPS deployment. So we deployed a sensor here to monitor this corporate system or this corporate network. We deployed a sensor here. We deploy a sensor here. This is the sensor. This sensor is an IPS. It's what we call the IPS, the intrusion prevention system. It's called this sensor. So to monitor this one, to ensure if there's anything coming from this gateway, it do not have access to all these hosts, all these corporate hosts in your organization. And then a way of providing cybersecurity is what we're looking at. So we also have one here to protect a sensor, this IPS sensor, to protect the management server. And then we also have one here, IPS sensor, to protect this web server and the domain name system server. Okay. Okay, so we have 3 segments here, and each of these has a sensor to protect The sensor in this case is the IPS in this regard. Both IPS and IDS. Okay, so we have them as sensors to monitor each of the segments. Okay, so this is how we deploy them. Now we go to another subheading, which is called the IPS signatures. So the signature is the big job now. Let's look at the exploit signatures. Okay, these are the different OSI model. We studied this in data communication. In data communication, we learn the OSI model, the several layers of the OSI model. Now we say the first layer is the physical layer, which include the cables and all this the computer. Then here is the data link. The data link layer, the network number 3 is the network layer, transport layer, session layer, presentation layer. This is the one we were trying to remember a while ago. The presentation layer and then the application layer. Now we're saying the exploit signatures are stored in the network layer, and to look after fragmentation attacks in the network, there are some type of attack that are notable in the network layer. And the IP option, they always attack on the IP addresses, the IP option, and the ICMP, the Internet Control Message Protocol, and the reconnaissance and the denial of service attacks. They found all of these are usually found in the network layer. Then in the transport layer, we have what we call the port sweeps and the port scans and the TCP synchronous attack. So all of these ones, they are found in the transport layer, the port sweep, sweeping of the port, the console, the port scan, all of this, they are found in the transport, okay, in the transport layer. Okay, the network has something to do with the IP and the protocols, the IP addresses and the protocols that are associated with the routers. Okay, that's what we have in the network layer. The transport has something to do with the port and the cursor and all of these protocols, as it were. Then another place where we have to work on the signature, the exploit, is the application layer. The application layer here is able to detect the DNS, reconnaissance, and DOS, denial of service, and it's also able to block the worm, the virus, the Trojan horses, and hardware and malware that attack the application layer. Okay, so we will look at the signature later on. Now let's take a look at the IPS signatures, the IPS signature. IPS, like we said, they are sensors. They are just intrusion prevention systems. Now, to stop becoming malicious traffic, the network must first be able to identify it. Must be able to identify it. Okay, must be able to tell what is it and how does it do that. Malicious traffic, they display distinct characteristics, right? Every malicious traffic carries what we call a distinct characteristics, or what is otherwise known as signature. Okay, every malicious traffic display distinct characteristics, and these distinct characteristics is what we call the signatures. So the IPS already have in a database have all these signatures of malicious attack. So any one that is coming that has the same characteristics as these signatures on the database, the system will raise alert. The IPS will raise alert, will display alert on the logs and inform the system. Okay, so a signature is a set of rules. It's a set of rules that the IDS and IPS use to detect typical intrusion activity, such as denial of service attack. Signature, if we are asked what is a signature, it's just a set of rules that IDS and IPS use to detect any intrusive activity in a network. Okay, a good example is denial of service, reconnaissance attack, malware, hardware, Trojan horse, and so on and so forth that are about to attack our system. So when we have such thing, a signature is just a set of rules that the IPS and IDS uses to detect this intrusive activity. Now, signature, they uniquely identify specific worm. They identify worm, viruses, protocol anomalies, and malicious traffic. IPS sensors, they tune to look for matching signature or abnormal traffic pattern. So they either look for matching signature because they already have in their database, the IPS already have in the database of the Cisco database, all the signature of all these attacks, the signature of all the attacks. So when the signature, the coming attack, it matches with what we have in the database, so the system, the IPS sensor is able to sense and alert the system that the system is about to be attacked. So not only the matching signature, also an abnormal traffic pattern. where there is an abnormal traffic pattern different from the normal pattern, it's able to detect it and report it. IPS signatures are conceptually similar to the virus that that files that is used by virus scanners. Okay, the virus scan software that is used. So the IPS signature is just similar to that. Okay, now let's take a look at the signature attributes. What are the characteristics or the features of the signatures? What does the signature has? One is that the signature have three distinct attributes. Number one of the attributes is the signature type. Okay, the signature type. We have two types of signature. We have the atomic signature and we have the composite signature. The composite signature is the stateful signature. The atomic is just one packet type of signature, just to detect one packet. Okay, that's the atomic signature. While the composite detect many packets, can be able to detect many packets. So another attribute apart from signature type, knowing the signature type, attribute of signature is the trigger, the alarm. Okay, the signature is able to raise alarm when it detects anything that is any anomaly in the pattern, or when it detects any signature. When it detects any signature that is already in the database, so it raises alarm. Number three attribute of a signature is action. Action. That's to prevent it and also to immunize the system against such a future attack. To prevent it and immunize it. So every signature has three characteristics or three attributes. One is the signature type, whether it's able to analyze it as atomic or composite signature. The second attribute is the trigger, is able to raise alarm that there is an intrusion. And the third one is the action, what it does with it, how it prevents the reaction and the reaction. Okay, so now let's go to signature type. We're going to look at them one after the other. We'll describe the signature type, we'll talk about the trigger, alarm, we'll talk about the action. Now let's talk about the signature type. Now, we said there are two types of signature. One is the atomic signature. What is an atomic signature? It's the simplest form of attack, as it consists of a single packet or single activity or even single event that is examined to determine if it matches a configured signature. You know, there's already configured signature on the database, okay, the IPS database or the Cisco CCP database. Okay, so there is already a stored signature, and once any data packet or activity or event that is coming into our network matches with any of the signature on the database, okay, then it will trigger alarm. If it does, an alarm is triggered and the signature action is performed. If it does not require any knowledge of past or future activity in order to carry out for this atomic signature. It does not require any knowledge of the past or future activities. No state information is required. Okay, that's why that's why it's called atomic. Now, a good example of atomic signature is a land attack. A good example of atomic signature is a land attack. Land attack contains a spoofed TCP synchronous packet with IP address of the target host as both source and destination, causing the machine to repeat itself continuously. So if you take a look at this Wiresharks, the interface from the software, you can see that the IP address of the source IP address is same as the destination IP address. So it's causing the machine to constantly and continuously repeat itself. This is a LAD attack. Okay, a LAD attack contains a spoofed TCP. Okay, it's spoofed. That's why you can see both the source and destination are similar. The spoofed TCP synchronous packet with the IP address of the target host as both the source and destination will be same, and it will cause the machine to constantly repeat itself. Okay, so it means there is an atomic signature detected. A good example is called a land attack. Now, still on the second one, which is a composite signature, still on signature type. The second one is the composite signature. This composite signature is also called the stateful signature, and it identifies, remember, it able to prevent many, detect many, not one event, many activity, many attacks, and so on and so forth. So it's a stateful signature, and it identifies sequence of operations distributed across the multiple hosts on the system, okay, over event horizon, okay, over event horizon. We have to define event horizon because it is a period of time that the length of time that the signature must maintain the state, the length of time that the signature must maintain the state, must be able to detect, must be able to work, okay? So usually require several pieces of data to match an attack signature. An IPS device must maintain state. Okay, now let's take a look at signature, still on signature time, the composite. The length of event horizons vary from one signature to another, depending on the type of signature that is being detected. So an IPS cannot maintain state information indefinitely without eventually running out of resources. So it cannot continuously, IPS cannot continuously maintain state information indefinitely, like without it eventually running out of resources. So we must be able to define what we call the event horizons. The event horizons therefore becomes the time that is designated for the IPS to be able to monitor the signature. So IPS uses configured event horizons to determine how long it takes for specific attack signature when an initial signature component is detected. So we should be able to define what the event horizon is in our configuration mode. So configuring the length of event horizon is a trade-off between what? Between consuming system resources, because it's going to consume a lot of system resources. So we have to give a specific time. If we don't give defined time, the whole network resources will be super consumed. So, but we have to have a trade-off between resources of the network being used and also the ability of the system to detect attacks that occur over the extended period of time. So there must be a trade-off between being able to detect attack and the system resources that is being used. So as a result of that, event horizon is a trade-off between these two. Now, signature files. Okay, because when we are configuring, we look at the signature file. A new thread identified, new signature must be created and uploaded to the IPS. Every time a new thread is identified, new signature must be created. Remember, these signatures are just copy of thread that has been identified, and they are stored in the system database, the IPS database or Cisco database, so that when such attack is passing through the system, it's able to raise alarm and the action can be taken in order to prevent this kind of attack. Now, to make this process easier, all signature must contain a signature file. So in order to make it easier, all the process has to contain what we call the signature file and uploaded to an IPS on a regular basis. So this leads us to what we call the signature file. Okay, so network deploying the latest signature files are better protected against network intrusion. So there should be an update of signature file that are constantly uploaded, or else then will be vulnerable. The signature file, for example, the land attack, remember we say is an atomic signature. The land attack is identified in an impossible IP packet signature. So it's identified. Let's say here is the Cisco configuration mode. Okay. So we're going to describe this one in a signature file contains the signature and many more. A signature file contains that particular signature that is being identified now and many more other signature so that it can be uploaded and stored in the database. Okay, now these are some signature example. These are their ID number, like 111. These are unknown IP protocol. These are TCP window size variation. These are just some examples of signature and their applications or description. Okay. Now we have what we call the signature micro NGs. We have what we call the signature micro NGs. To make the scanning of the signature more efficient, more effective, and efficient, and more robust, Cisco iOS software relies on what we call the signature micro NGs. Okay, so the same way you have search engines in the Google, we also have Cisco NG, micro NGs. Okay, SME, Cisco, signature micro NG, developed by Cisco, which categorize common signature in groups. Okay, put them in group. Now, Cisco iOS software can then scan for multiple signature based on the characteristics, that the group characteristic, instead of one by one, instead of one at a time. So every group, signatures are put in group and they have similar characteristics. So the software is able to scan for multiple signature using these group characteristics. Okay. Now the available signature micro NG vary depending on the platform, depending on the Cisco iOS version that you're using, version 4, version 5, and the version of the signature file also that you're using. So this ability of the signature micro NG to do its job properly depends on the platform where you're using it, depends on the Cisco version that you're using. It also depends on the version of the signature file that we are considering. Signature macro NG are constantly being updated because we have the version 4. We have the version 4 now. Latest one, we have the version 5, which is an improved IPS signature format, right? Okay, so these are some of the Cisco micro NGs and their description. Cisco iOS release define 5 micro NGs. One is the atomic, the signature or atomic signature. Where it's the level, the surface, what it does, it examines SQL packets such as ICMP, that's Internet Control Message Protocol, and UDP, User Datagram Protocol. Okay, then we have another one called the service. This one examines many services that are being attacked. Okay, and then the string, it uses regular expression pattern to detect intrusion. The multi-string support flexible pattern matching and thread lab signature. There are others. There are 5. 1, 2, 3, 4, 5. Others, internal NGs that handles miscellaneous signature. Just an internal part of the NG that handles any miscellaneous signature that are available. Now, signature micro NG, the different version. We have the version 4, version 5, comparison of both versions. Okay, so it's just where the application lies or the description. Atomic IP, that the one that works on the IP for both version 4 and version 5, provides simple layer 3 IP alarm. So if there's any attack on the IP address, alarm will be raised. Atomic ICMP for version 4, but in version 5 it's still atomic IP. What it does is to provide simple Internet Control Message Protocol based on the parameter type code, types, code, sequence, and IDs, so and so on and so forth. So these are some of the different versions, what the layers of job they do. Now let's move on to uploading signature. Uploading signatures. Okay, Cisco investigates and creates signature for new threats as they are discovered and publishes them regularly. So that's why when you install in your system, your Cisco's in your device, in your computers, then you should always update regularly from Cisco database so that it will be able to continuously create, detect any new signature that is that is going to affect your network. Now, lower priority IPS signature files are published bi-weekly, twice a week. If the threat is severe, Cisco publishes the signature file within hours of identification. If this threat is very serious, Cisco will publish within hours of identifying the attack. Now, you see why it's good to use Cisco system. They will help you. Once you install them, we're going to talk about the installation, configuration, and all of these things in your network. And then Cisco will continuously update your system and help to protect the system from your network from being attacked. Then another update is the Cisco update the signature file regularly to protect the network. Okay, and we say also new signatures are downloadable from CCO interface. Okay, now here is the Cisco interface. Here we can download the updated signature. Okay, so you click on download software. You come to 595 and then you download. Okay, this is the download interface. Cisco iOS intrusion prevention feature software. Okay, you can download. Okay, but you must have a login, username and password to log into the system. Meaning you must register with Cisco in order to be able to download this software and install it on your network to protect your network. Maybe you have to pay some money to Cisco, and then you'll be able, they will create an account for you. Then you'll be able to download the intrusion prevention system and use it to protect your network. Okay. So once you register, you have access. Maybe you've made the payment or something. You click download now. Then you're able to download the file. You download and put in your flash. Okay, and install your router and every other devices on your network, as it were. Now let's go to signature trigger. We've looked at the first one, which is the signature type. Remember I said we're going to do the three features, the three characteristics or features of a signature. The signature type, signature trigger, which is the alarm, and then the action, signature action. Now let's look at the signature trigger. Signature trigger, which is called the signature alarm, is able to trigger for an IPS sensor. We say the signature trigger for an IPS sensor is anything that can reliably signal an intrusion or detect an intrusion or security policy violation. So when there is security policy violation, then this alarm will trigger. Okay. Now the Cisco IPS 4200 series sensors and Cisco Catalyst 6500 use this IDSM. They use 4 types of signature trigger. The number 1 is the pattern-based detection, policy-based detection number 2, anomaly-based detection number 3, honeypot-based detection. This honeypot is usually used for management system. Okay, but these first 3 are generally used for the entire system. Now let's take a look at the first one, which is the pattern-based detection. Okay, remember we're saying the trigger, the type of trigger. So the pattern-based detection. Pattern-based detection signature-based detection, and it's the simplest triggering mechanisms that the IPS system uses to create an alarm because it searches for a specific predefined pattern. So once you find the pattern, then it will raise alarm. The pattern base, it's looking for a pattern. Okay, a pattern that has already been stored in the database. Once the pattern is detected, then it triggers alarm that there's an attack, a denial of service, or a malicious software, or anything that is about to happen to the network. Now, the IPS sensors compare the network traffic to a database of the known attacks and trigger an alarm or prevent communication if a mismatch is found. Okay, the second one is the policy-based detection. Similar to pattern-based detection. The policy-based, this one is based on the specific, based on the administrator's behavior, suspicious or historical behavior. Okay, so we say instead of trying to define the specific pattern, the administrator defines behavior. Okay, this one is based on behavior. Behavior is referred to policy in this regard. It's based on the behavior of the attack that are suspicious, based on historical analysis, based on what has been done in the past. So, okay, once you see a funny behavior from your packet that is entering your network, then this detection system raises alarm. It's called the policy-based detection. The third one is the anomaly-based detection. In the anomaly-based detection, it can detect new and previously published attack. So it detects the previous published one and the new ones. Normal activities is defined, and any activity that deviates from this profile is abnormal, and it triggers a signature action. All the normal activities are defined, but if there's deviation from the normal, it will trigger a reaction. So these are the four, and their advantages are disadvantages, the four type trigger or alarm pattern that is used. The pattern detection, which is the signature based, the policy based, which is behavior based, and then the anomaly, which is profile based. The anomaly is based on profile. Okay, then the honeypot. Okay, these are the advantage and disadvantage. Now, tuning alarms. Tuning alarm. We're going to do all this in the configuration mode. Triggering mechanism can generate various types of alarm, including the true positive, which is attack traffic. The network activity does is to attack the traffic. The IPS activities to alarm is alarm generated, and the outcome is ID setting. So we have true negative. The network activity is the normal user traffic. The IPS activity is no alarm is generated when you're using true negative, and then the outcome is ID setting. Is in the ID setting. Then the false positive, the network activity is normal user traffic also, and then the IPS activity is alarm is generated when there's false positive, and then the outcome is tune alarm. The false negative, the network activity is attack traffic, and then the IPS activity is no alarm is generated, and true alarm is the outcome. Okay. Tuning alarms, false positive. False positive alarm is an expected but undesired result. It's expected but it's not what you are looking for. Why? Because it could be just any activity within the network can be detected. Okay, it doesn't really mean attack is about to take place. So, okay, the false negative, the IPS fails to generate an alarm after processing attack traffic. See, false negative. The IPS fails to generate an alarm after evil processing attack traffic. So this one is imperative that the IPS does not generate false negative. Okay, now let's go to tuning IPS signature alarm. Tuning IPS signature alarm. A signature is tuned to one of four levels based on the perceived severity of the signature. It's tuned to one of four levels. When you're tuning, first of all, we're going to talk this for either you look at the action or the fidelity rating or set severity to either high, low. We're going to look at these four levels. Okay, set severity to what? But you know, this is your CCP, Cisco Configuration Professional Interface. So when you come here, always you click on configure, and then when you click on configure, you go to security, look for security, you click on security. See, you go to security, not router. If you're configuring router, is a different thing, which we looked at in the previous chapter 3. Then when you click on security, are you installing firewalls? Are you working on firewall or VPN or public key to infrastructure? No, we are working on intrusion prevention. So you click on intrusion prevention. Okay, you click on intrusion prevention. So when you click on intrusion prevention, are you creating IPS? No, it's already created. We just want to edit. So you click on edit IPS. So when you click on edit IPS, it gives you these options. It gives you all these options. You go to signature. You go to signature. After you click on edit IPS, go to signature. Click all categories. Click all categories. When you click all categories, it will give you all this option. Then you go to set severity to. set severity to high, informational, low, or medium. So depending on what you want to set it to, these four options, then you set it to any of these four options. So tuning the IPS signature alarm to low, what does it mean? To medium, what does it mean? To high, and to informational. To low, it means the abnormal network activity is detected that could be perceived as malicious, but an immediate threat is not likely. Okay, that's low. Okay, if it's medium, abnormal network activity is detected that could be perceived as malicious, and we say an immediate threat is very likely. To high, attack used to gain access or cause a denial of service are detected, and an immediate threat is extremely likely. So if you see high, it means danger, denial of service is there, and we need to do something as fast as possible. Informational means that activity that triggers the signature is not considered as immediate threat. The information provided is useful for information sake. So we go to the signature action. We've looked at the signature type. We've looked at signature alarm. Now we're going to or trigger, alarm or trigger, whichever word you use. We looked at signature type, signature trigger, or signature alarm. Now we're going to signature action. These are the three features of a signature, like we mentioned earlier on. Now the second one is the IPS signature action. Okay, whenever a signature detects an activity, the activity for which it's configured, the signature triggers one or more action. Okay. Now, these actions can be performed. Either it allows the activity, or it drop or prevent the activity, or it block future activity, or it generate an alert, or log the activity, or reset TCP connection. So, but in this case, the assigned action that we want to take is produce alert. Okay, we just want to produce alert whenever it detects any anomalies or pattern or whatever. Okay, so we set it to produce alert. That's the actions that we are taking for signature. Now, managing and monitoring IPS. Managing and monitoring IPS. How do we manage and monitor IPS, intrusion prevention system? Event monitoring and management. There are two key functions of event monitoring and management. One is the real-time event monitoring and management. The other one is analysis-based. So one is the real-time, which is like IPS. The other one is the analysis based on archive, like IDS, like reporting, IDS. Now, event monitoring and management can be hosted on a single server or separate server, depending on how large the organization is. Is that okay? So it's recommended that a maximum of 25 when tooled sensors reports to a single IPS. Okay. Okay. Event monitoring and management can be hosted on a single server and on separate server for a very large one, for very large system. Now, we say it's recommended for maximum of 25 well-tuned sensors to report to a single IPS management console. So, like 25 tuned sensors to report to an IPS management console. Okay, maximum, this maximum, meaning you cannot exceed 25 sensors reported to a single IPS management console. So you can have it less than that 25. You can have 5, 10, 15, 18, 20, 20 something, 25 maximum. Okay, now we move on. Event monitoring and management. Still on event monitoring and management. Several Cisco device management software solutions are available to help administrator manage the IPS solution. Now, the first one is the Cisco router and security device manager. We have what we call we're going to look at each one of them. We have the Cisco router and security device manager to help to monitor any event that is taking place on the device, on the IPS. Okay. We have Cisco IPS Manager Express. This one is very good. We have Cisco Security Manager. Okay. So we're going to talk about these three. The first one, before we talk about them, we look at the Cisco's Configuration Professional, which is the interface where we do all of these things. Okay, Cisco iOS IPS monitors and prevent intrusion by comparing the traffic against signature of known threat and blocking the traffic when a threat is detected. Now, this CCP allows administrator to control the application of Cisco iOS IPS. IPS is the sensor we are talking about. Remember that. Okay, on interfaces. Import and edit signature definition files. Okay, using the SDF from the cisco.com, and to configure the action that Cisco iOS IPS is to take if the threat is detected. So we're going to look all this one. When we're doing the configuration, you understand now, because we want to look at each of them. Now let's take a look at the first one, the IPS Manager Express, which I say is good. Cisco IPS Manager Express is a graphic user interface based configuration and management tool for IPS applications or appliances. Okay, here you just go to CCP and go to the management system. Okay, and then you will install this or you configure this software in order to be able to do prevention for you and management. Okay, it's an all-in-one IPS management application to provision. So it provides, monitor, troubleshoot, and generate reports for up to 5 sensors. So it's for managing the sensors, the IPS in your system. So when you install this IPS Manager Express, able to provide and monitor, troubleshoot, and generate reports for about 5 sensors for you. So it supports live RSS feeds for most recent security intelligence. For downloading and installing the approximately 120 megabits set up the execute file, 2 desktop shortcuts are created, one for actual sensor and the other one for the demo mode only. So you can see that you can install this on your system, because before you can install CCP, you must install this manager first on your system in order for the CCP to work on your system. So you have to download this one to support the installation mode, the CCP, Cisco Configuration Professional. You have to install the manager. The second one is the Cisco Security Manager. So you can choose any of this manager to install in your system before you install the CCP. Is that okay? Cisco Security Manager is a powerful but very easy to use solution to centrally provide all aspects of devices configuration and security policies for Cisco firewalls. So it's able to support all your firewalls, all your VPNs. We're going to treat VPN in another chapter, and your IPS. In this chapter, we are dealing with IPS. Chapter 4, this chapter 5, we are dealing with IPS. In chapter 4, we dealt with firewalls, right? Chapter 6 or 7, we'll be doing VPN. Okay, so this system, this software manager is able to support all of this. Now, we say it includes a signature update. Okay, and it updates the wizard, allow easy review, easy use, easy editing prior to any time you deploy it or you install it on the system. So this manager support, just like you have Wiro. If you want to be able to convert file to PDF, you have to install a Wiro, right? A Wiro software. The same way, before you can install the Cisco Configuration Professional, you have to install any of these software manager I've mentioned, the Cisco Security Manager software. Either you choose the Cisco Security Manager software or you choose the Cisco IPS Manager Express. Any of this one will support your CCP configuration and enable your IPS and firewalls and all the VPN that you want to do on the system to prevent any attack on your system. Is that okay? Okay. So the third one is the Cisco sensor-based network. Okay, this is a sensor-based network. Say, with global correction, Cisco IPS devices receive regular threat update from the centralized Cisco database. You know, Cisco has a threat database called the Cisco sensor-based network. This is a centralized database from a Cisco. Okay, so anytime you have the Cisco IPS device that is installed in your computer, it gets an update from this Cisco database automatically. It's an online database. As long as you are subscribed to Cisco, you get an update from this centralized database from Cisco. Okay, for threat database, and it's called the Cisco network sensor-based network. Cisco sensor-based network. That's what it's called. So once you register with Cisco, you continuously get this update of threat database from this centralized database. The Cisco's sensor-based network contains real-time, both the real-time detailed information about any known threat on the internet. Okay, this Cisco-based network is a database, okay, threat database by Cisco. So it contains real-time, detailed information about any threat that is found on the internet. Okay, so participating IPS devices are part of the sensor-based network that will receive global correction update that includes information on the network devices with reputation for malicious activities that is taking place on the network or that is taking place on the internet. So once you register, that's why they call you participating IPS device. If you register any of the IPS device, like the IPS sensors or any of the IPS device on the sensor-based network, Cisco sensor-based network, then you will get an update on any malicious activity, and it will be able to provide protection, detection, and protection and prevention for your system. IPS global correction. Okay, we say this is Cisco's IPS sensors application. Okay, this is the reputation database that once you install the event manager or the UI support, then you are able to get events from management tools such as the command line interface, IDM, and so on and so forth. So you need to install the event manager or this. Then reputation client, look at the database query, Cisco data client, and this is the reputation, this is the global correction server, and this is telemetry. Okay, so this is the global system. Okay, now let's move up quickly. Configuring Cisco iOS IPS. Now we're going to configuration. Okay. Now Cisco iOS IPS. Cisco iOS IPS enables the administrator. You have to configure them before you can use them. The administrator to manage the intrusion prevention on routers, right? That use Cisco iOS release on 12.3 tier 4 or later. Okay. Now Cisco iOS IPS monitor and prevent intrusion. Not only monitor, once you install it, it will help you to monitor and prevent any intrusion by comparing traffic against the known signature, you know, right? Against any known signature that is on the database, okay, that is on the Cisco network-based database, okay? So once it compares them, and then it will block them. Once it's a known one, it will block the traffic when the any threat is detected, okay? Now we say there are several steps that are necessary to use the Cisco iOS command line interface to work with iOS IPS version 5 format signature. Because previously we have the IPS version 4 format signature, and now we have version 5. So there are a bit of configuration you need to do in order to enable them to support each other. They can support each other actually. Now, these are steps to implement the Cisco iOS IPS. Number one is to download the iOS IPS file. So number one is to download the file from the internet, from the Cisco's website. Number two is to create an iOS IPS configuration directory in a flash. Okay, you configuration directory in a flash. Number three is to configure the iOS IPS crypto key. Okay, you have to install or configure the crypto key. Number four is to enable iOS IPS. Okay, you have to enable it, iOS IPS, but this one requires a bit of steps. Then number five is to load the iOS IPS signature packet onto the router. Now we're going to look at them one after the other. The first one is to download the iOS IPS files. Now this is it, download the iOS IPS file. Now this is the file. Download the iOS IPS signature file and public crypto key. So not only download the file, the signature file, you have to download the public crypto key. So you are downloading two files. This is the iOS file, and this is the public crypto key. So you have to download these two files. Okay. Once that is done, then we move to the next stage. Okay. Number two is to create iOS IPS directory in a flash. To create it in a flash. Okay. Create a directory in a flash to store the signature files and the configuration. You have to create the directory in a flash to create the directory in a flash to store the signature files so that you can store all the signature files and configuration. We're going to do it, we write the command, okay, in the command line interface, in the privileged execute mode. Okay, so use the mk directory, okay, which is privileged execute mode command to create the directory. Use the rename, see, current name, new name command to, you have to change the name, whatever name it has before in the Cisco server, you have to change it to a name you want now. Now to verify the content of flash, you enter the directory flash privileged execute command. So you say router hashtag mk directory IPS. See, create directory, file names, created flash, blah blah blah, what you have entered. Everything will be displayed here. Is that okay? So we'll move to the next one. Number three is to configure an iOS IPS crypto key. How do you configure it? After you've downloaded it, you have to configure it. So configure the crypto key to verify the digital. You have to configure the crypto key to verify the digital signature for the master signature file. Okay, this is the master signature file. This is the master signature file. So we have to configure the crypto key to always verify the digital signature for the master signature file. Now the file is opened by Cisco to guarantee its authenticity. It's signed. Cisco signs it. They always sign this file. There's Cisco crest on it to show that it's authentic and it has integrity. Okay. To configure how do you now then configure the iOS IPS crypto key? In order to do that, you have to open the text file and then you copy the content of the file and paste it in the global configuration prompt in your command line interface. You have to copy it and paste it on the global configuration prompt. So you have to copy all the content. You know, you downloaded the key, right? You open it and copy all the information in it and paste it on the global configuration prompt. We're going to see it. Okay, let's see it. The text file issues the various commands to generate RSA key. Now look at it. See, configure an iOS IPS crypto key. Highlight and copy the text in the public key file. You remember this is the public key file. Okay, you have to copy. You have to highlight everything and copy what you see here in this public key file from Cisco and paste it on the global command configuration prompt. Okay, the next is to paste this, everything you copied here is to paste it on the global configuration prompt. Router 1 hashtag config terminal, router hashtag, then you paste it. After you type this command, you paste it. So you see, Now, when you paste it, number 3 is to configure iOS IPS crypto key. So the third issue, you issue the show run command to verify that the key was copied. Once you type router 1 as the show run, once you type this command, it will display everything. See, the key was copied. The key was copied. Crypto key public chain RSA. Name key RAM Cisco public signature. See? So the key, these are all the key. The key strings are all of this one. The specific strings are all of this. Okay, all these ones are crypto characterization to ensure to protect the system. Okay, so let's move on. Configure an iOS crypto key. Still on this one. At the time of the signature compilation, an error message is generated if the public key is invalid. Okay, it will show you an error message. It will not display what we just saw. To display an error message if the right key was not copied. So if the key is configured incorrectly, the key must be removed and then reconfigured using the no crypto key public chain RSA and no name key RAM Cisco public signature command. Okay. Now enable iOS ILP. Now these are some commands to enable iOS IPS. Now the first is to identify the IPS rule name and specify the location. Okay. We say use the IP IPS name. You say router 1 config IP IPS name. That's the first thing you type. Okay. Then the next is an optional. You can use what we call an optional extended or standard ACL. You know, we looked in chapter 4, we studied ACL. It can be used to filter the traffic. You use this one, APS, to filter traffic. And the traffic that is denied by the ACL is not inspected by the IPS. Once the traffic is denied by ACL, the IPS will not inspect it. Okay? So we say use the IP IPS configuration location flash. The command to configure the IPS signature storage location is this. You say router 1 config hashtag IP IPS name iOS IPS. Router 1 config IP IPS name IPS list. Okay, it will give all the list named numbered access list. Okay, then router 1 config hashtag IP IPS configuration location flash IPS. So these are the commands for enabling the iOS IPS that you have just configured. So still on enabling, we also enable SDEE and the logging event notification. We also enable the SDEE and the logging event notification. The HTTP server must first be enabled using the IP HTTP server command. Okay, you have to enable it, the IP HTTP server command, by typing this command router 1 config hashtag IP HTTP server. Once you type this, then you are on your way to enabling the HTTP server. Okay, then the next is to router 1 config hashtag IP IPS notify SDEE. Because SDE notification must be explicitly enabled. You must enable it. In order to enable it, you have to type this command. Router 1 config hashtag IP IPS notify SDEE. Then we say router 1 config hashtag IP IPS notify log. Okay, you must IP IPS notify SDE. Okay, so we also notify the logs. Okay, and then that's it for this one. Now we move on still. We say configure the signature category. All signatures are grouped in 3 common categories. No, the first one is all. Remember, we normally use all most of the time. We have the basic, we have advanced. So it depends on which one we select. Okay. Signatures that iOS IPS uses to scan traffic can be retired or unretired. What do you mean by retired signature and unretired? Retired means that the iOS IPS does not compile that signature into memory, does not compile it and put it in the memory. But unretired means instruct the iOS IPS to compile the signature into memory and use it to scan the traffic. So that's the unretired one. Configure the signature category. Okay, what we do is when the iOS IPS is first configured, all signature in all categories should be retired. When we first configure it, we have to retire all signature in all categories. And then we now select signature that should be unretired. Okay. So that the reason is that to save memory and so on and so forth. We first of all retire all, and then we select the one that we want to keep unretired. So to retire an unretired signature, first enter IPS category mode. You cannot retire signature or retire them if you don't enter the IPS category mode using the IPS signature category command. So this is it. So you say in order to retire signature, you come to your global configuration prompt. You type router 1 config hashtag IPS. No, IP is internet protocol. IPS is intrusion prevention system. IPS signature category. Okay, you have to enter this first in order to be able to retire or retire signature. Okay, then before you follow it with router 1 config IP category hashtag category all meaning all of them. Then you have to router 1 config IP category action. What action you going to take? Hashtag retire true, meaning you first of all retire all of them to save your memory. Okay, then you click on exit, action exit. Category iOS IPS basic. Okay, this is for basic, retire false, meaning don't retire them. And then exit. Okay, so when you now say in the second phase, next to use the category name command to change the category. Okay, you change which category, which one you want to retire. This one retire first. So it has specified some that should not be retired. Okay, so this is that for now. Configure the signature category. Still not configuring the signature category. We say apply the IPS rule to this desired interface and specify the direction. Use the IPS rule, either in or out interface configuration command to apply the IPS rule. Now, when it's in, what do we mean? When it's out, what do we mean? The in argument means that only traffic going into the interface is inspected by the IPS. So when you put in, you are saying only traffic that is going into the interface. When you put out argument, the out argument specifies that only the traffic that are going out of the interface is inspected. So this is the configuration in order to specify the signature category. At our config hashtag interface gigabit ethernet 0/0. Okay, you are configuring the interface. Then at our config interface hashtag IPS iOS IPS in. So you are saying you should inspect the IPS should inspect the what is coming in, the traffic that is coming into the interface. Then you now say at our config interface hashtag IPS iOS IPS out, meaning it has to do all the ones that are coming in and all the ones that the interfaces, all the packets or whatever you want to call it, or traffic that are going in and going out should be inspected by the IPS. That's what we mean when you configure this on the interface. Then you click on exit. You type config exit. Okay. Now load the iOS IPS signature. How do we load the iOS IPS signature? To load or upload. Upload the signature packet to the router using we use what? File transfer protocol or trivial file transfer protocol. So is either we use this protocol FTP or TFTP to upload. the signature packet into router, to upload the signature packet into router. So to copy the downloaded signature packet from the FTP server to the router, you always have to ensure that the ID config parameters at the end of the command are intact. Okay, so look at it. You say route 1, copy FTP Cisco, you put the address, the IP address, iOS 376 S376 packet ID conf. So when you do this, you will run everything on the engine, okay, on the IPS. Now load the iOS IPS signature, still unloaded. You verify that the signature packet is properly compiled using the show IP IPS signature count command. How do you do that? You just type on the global configuration prompt by typing on router 1 config router 1 hashtag show IP IPS signature count. It runs everything out and see if everything is in order. If it's not in order, you see error. Okay. Now we go to another section, configuring IPS using CCP. Now, the first one we looked at was configuring them using the global configuration prompt, right? Global configuration prompt, GCP. Now, we want to configure using the Cisco configuration professional, okay? We want to configure using the Cisco configuration professional. To do that, you have to increase the Java memory heap size. Okay, CCP needs a minimum of a Java memory heap size of about 256 megabytes in order to support your iOS IPS. So you have to increase, in case your Java memory heap size is not up to 256, you have to increase it in order for you to configure or use the CCP, okay? Then once that is done, you exit the CCP and open the window control panel. Once you increase it, you exit, and then you open the window control panel. You click on the Java options and open the Java control panel, and then select the Java tab and click on the view button under the Java applet run, and then you run applet runtime settings. Then in the Java runtime, we're going to see what are you going to do. You just have to enter this. You copy this and paste here, Java runtime parameter, paste it here, click OK. Okay, once you go to Java runtime setting, just copy this and paste here and click OK, and then you're good to go. It will open the configuration iOS IPS using the CCP. Okay, this is how it looks. You can see all the management files, all the functions. Okay, it can be used on interface management, router security. Under security, you have your firewalls, you have your VPN, you have the public key infrastructure, you have the NAC, you have the web filter configuration. Okay, and so you have intrusion prevention, and so on and so on. You have ports to application mapping, and so on and so forth. You have security audit, and so on and so forth. But in this case, we are dealing with intrusion prevention. So we click on the intrusion prevention. Once you click on security, then you come and click on intrusion prevention. Then you open this interface, and then you click create, because now we want to create the IPS, and then we put every other thing that we need to put. Okay, now let's move. And then when you open this, you see this interface. It depends on what you want to do, intrusion prevention, right? So what are we enabling? We're selecting the interfaces that we want to enable. The fast Ethernet 10, we click on the inbound. The fast Ethernet, anything that's coming should come to the fast Ethernet 0/1. Then the outbound, we click on the serial 0/0 interface. Then we click finish. Okay, we click finish. Okay, so then the next thing is the download the signature file. You see, this is the Cisco configuration professional, so we can use it to download the still on the intrusion prevention area. Then you click on the signature file and public key. You see, go to signature file and public key. Then you click on get the latest signature from the cisco.com and save to PC. You have to put the directory, the location, where it will save it to, and then the username and password so that people cannot just have access to yours. You know, we say you must do a CCO login. Okay, you must do a CCO login. And then you put your username and password and then you save. Okay. Then another thing you do, you select the signature file. Okay, which signature file you want to select. You say specify the signature file you want to use for your iOS and IPS. So you click on specify signature file on flash. It could be on flash. There is on flash. There's specify signature file on using URL. There is also specify signature file on PC. So in this case, we click on the flash. Okay, specify it on flash. Then you move to the next. Okay, the next one is configure the public key. So to configure the public key, like we said, you have to see, we're still on the intrusion prevention. Then we're still on signature file and public key. You click on signature file and public key. You click on specify the signature file you want to use with iOS IPS. Okay, see signature file. You click on it, the signature file that you want to use. Okay, here. And maybe you copy and paste it here. And then remember this one, you copy the public key, you paste the public key. You paste the public key here. You paste the public key and then you go to next. Okay, here is to configure the public key. You put the name of the public key here, you paste it here, and then we go to next. Then what else? We specify location of signature file, the location. Okay, still on the prevention, you go to location, configuration, location, and category. Click on configuration, location, and category. Configuration, location, you select. Category, you choose advanced. Okay, category, you have all, you have advanced, you have basic, so you choose advanced. Location, you choose which location. Okay, we go to the next one. Then after that, once you reach finished, click finish to display summary of everything. This is your key, your public key, everything. So the IPA wizard is displaying this, is displaying the what you have done. Okay, the installation. This is more or less installation and so on and so forth. Okay, okay. So it's display this, and then modify the signature. Anytime we want to modify the signature, this example shows how to retire individual signature. In this example, signature 6130 using the 6 subsig ID 10 is retired. And you can see it from this configuration. So you type on the command interface, router one of hashtag configure terminal. There you write the IPS signature definition, meaning you now put the signature 61310. Okay, you put the status, you say retire true. There's retire true, retire false. Retire false means or retire it. Retire true means it's retired. Okay, so this is the how you modify the signature in the configuration mode. You can play with it and either retire or retire signature. Still on modify signature. We say this particular example shows how to unretire all signatures that belongs to the iOS IPS basic category. So you write the router one configure hashtag configure terminal, and then you write router one IPS signature category. Signature iOS IPS is basic because you are showing is basic, and then retire false, meaning unretire. You unretire them. When you say retire false, means you unretire the signature. Unretire signature. Okay, once you write retire false, and then that's it. Then change action for a signature. The action you can configure, you use configuration mode. Okay, in the router config terminal, router config IPS signature definition, you put the signature that you're talking about, signature 613010 ng, and then event, Ratawa config, you just put event action product alert, put alert for the event, the produce we want alert to take place. Event action deny packet inline, meaning it's an IPS. Event action reset TCP connection, and then exit. Okay. Then if you want to change action for a category, same way, you just go to the basic, we stay on the basic product, you say alert, event action, deny packet inline, deny, you say this one deny, and then event action reset TCP. So here you put deny, unlike, here, unlike the one just now, event action, deny packet, okay, inline, event action reset, here event action, deny packet, okay, inline. So once you type all this command, you are good to go. Okay, here is the modifying the iOS IPS signature. Like we always say, you go to, once you open your configuration, CCP, configuration professional, you go to your security, click on intrusion prevention, then you come here, you are not creating now, you already created this thing. Here we want to edit, click on edit IPS. Once you click on edit IPS, it will take you to these 4 actions, whether you want to carry out an action, fidelity rating, or set severity to. So in this case, we want to set severity to. First of all, before we reach here, you have to click on all signature, so that this all signature will open. If you click on configuration will open. If you click on UC protection, telepresence, OS attack, or anything you click on, that's where you'll be working on. Antivirus, worm, Trojan, that's where. Then we are doing all categories. So in the all signature, under the all category, all signature, we open. Then we see this 4 action. We set to this 4 action. Severity to what? To high, to informational, to low, and to media. We already explained what each of this one means. Then we say tuning a signature. Tuning a signature to work well. We always tune it to produce alert. Okay. For tuning, we set it to produce alert. We say go to configure, security, go to security. After security, go to intrusion prevention, and then click on assign action. Okay, click on action. Just now we went to set severity to either high, low. But in this case, in the next case, for action, you click on actions. Once you click actions, it will bring all these actions. Whether you want to deny attacker inline, or you want to deny connection inline, or you want to deny packet inline, or you want to produce alert. In this case, we want to produce alert. So we click on produce alert, we click OK. Okay. In this case, we want to edit a signature. If you want to edit a signature, it's still on the same process. You click on configuration, go to security, then click on intrusion prevention, and then you click on edit IPS. When you click on edit IPS, you go to all categories. In the all category, you click on all signatures. Click on all signatures. So when you click on all signature, all will displays. Okay, display. Then you'll be able to edit a signature that you want to see. We click, you see, when you say all signatures, look at all of them. But we will click on the one we want to edit. This particular signature 11004. You click on it and edit it to what you want. Is that okay? If it's this one you want to edit, you click on it and then you edit the signature for Adobe Flash players. Okay, so it depends which signature you want to edit. So this is how to do them in the configure them or play with them or manage them in the CCP. The signature parameters. You want to edit signature, still on the edit, just now, edit the signature. Once you click on this, we are here. Under the edit signature, you go to produce alert, right? Produce alert. You want it to always produce alert and inform us that there is a denial of service that is about to take place or a Trojan horse that is about to affect the network. Verify iOS IPS. Okay. Now, to verify is just to run some command. Router 1 hashtag show IP IPS all. Once you do that, you type that command in the command line interface. it will display all this or in the CCP configuration interface, it will display all that you have here to show. Then if you want to view configuration, what do you need to type? You have to type router hashtag show IP IPS configuration. Once you do that, it will display all the configuration that you have on your CCP. If you want to view IP IPS and the IPS interface configuration, you write router1 show hashtag show IP IPS interfaces. Once you put IP IPS interfaces, and then you show all the interfaces that are available, the fast Ethernet 0/0, all the interface Ethernet 0/1, all the interfaces that are available in router 1 will be displayed. Then if you want to do show signature status, what you need to command you need to type is router1 hashtag show IP IPS signature include 5000. Once you put this, it will show the status. It will display the status in the CCP. Then view alarm and packet statistics. So router1 hashtag show IP IPS statistics. IP IPS statistics. Once you do that, you display everything that is available. Now verify the IPS configuration. To verify, like we always do, you go to configure, click on configure. Once configure, it will show you all this one. Then you click on security, then you go to the intrusion prevention. Then you click on edit. Once you click on edit, then edit IPS. It will show you the interfaces. Edit IPS, then we will click on edit IPS. Then we click on interface. Okay, interface will show. You click on the interface, and then you click on all interfaces. All the interface will display. Then you highlight the one you want to edit. You highlight the one. No IPS rule is enabled, so you may enable it. That's why it's off. Status is off. So you may enable the IPS rule for this interface. Okay. So monitor iOS IPS. You just router1 configure terminal. Then you put the login, the IP address 192.168.10.100, the IP IPS notify log, and then login on. That's it. And then also router1 for IP router1 config terminal IP HTTP server, IP HTTP server, secure server, IP notify SDEE, the IP SDEE vet 500. Then you close. So on CCP syslog, all we need to do is we just go to monitor, right? This time around, we're not on the configuration now. We want to syslog. You want to monitor. You want to see what is happening. So all we'll be doing, be clicking on configure. That's all we'll be clicking on. Now we click on monitor. Once you click on monitor, then you go to router. You go to router, click on router, and then you click on login. Once you click on router, click on login. Then you click on syslog. Then you select whatever application what you want to do. Okay. It will show you whatever. It will display the syslog. Okay, what you have. So these are other materials that can help you in this Cisco IPS. www.cisco.com.go.ips. So you can browse this website to get some practical aspects in order for you to be able to configure for your whole practice. You may also use networkworld.com/community/load, and then you may also use networkworld.com/community/load and so on. So you may use any of these three websites to help you in the configuration in order to get extra things that you need. So thank you for joining us. That's the end of our today's class.